Dear students, good morning everyone. My name is Sheikh Rahman. I am working in Anurag Engineering College as an assistant professor in civil department. Today we are discussing about one of the beautiful topic, very important topic according to the groundwater hydrogeology. So nothing but a groundwater hydrogeology entire course point of some of the properties will be playing a crucial role, important role for that knowing about that one. So those topic, that particular important, very important topic behind the very backbone related topic we have to be discussing. The topic name is nothing but the properties, the rock properties affecting groundwater. So first of all, the key rock properties that influence the groundwater storage and movement and porosity and permeability. My dear students, in this case of maybe rock properties or most of all including by the those are affected by the storage and movement of groundwater point of the porosity and permeability play a crucial role, important role for groundwater movement and groundwater transpiration point of groundwater storage point of groundwater permeability point, groundwater transmissibility point. So first of all, the porosity refers to the amount of void space in a rock, within a rock, while permeability describes how well those spaces are connected along water to flow through. A brief information about the porosity refers to the how much of the void spaces will be there in that rock, within rock, while permeability describes how well those spaces are connected along water to flow through. For example, a rock we take, rock we take for example point of in the rock how much of the space or voids available, that we are saying as the porosity, number of voids by total volume of the rock, that will be represented as the porosity. Those what we are having those and spaces, how to help to transmit the water one place and another place, how to discharge the water with help of that porosity or maybe course point of that will be decided as the variability. I know you understand that one. So I hope you understand. So different rock types have varying properties and porosities and permeabilities impacting their ability to act as aquifer, water bearing layers. So nothing but what is mean by aquifer here? Water bearing zone in subsurface. Subsurface having any water availability zone, water available zone and water bearing zone, that we are called aquifer, or maybe water bearing layer also called aquifer. So in this case of different types of rocks will be there available in nature, maybe igneous rocks, metamorphic rocks and sedimentary rocks. Each and every rock having their own porosity nature and permeability nature, not to be similar, not to be same for different kind of rocks point of. Based on that rock type, those porosity and permeability should be changed, not to be similar, not to be same. Based on that properties point of, it will be changed. Okay, rock types point of. So for example, you take any igneous rock, very tough rock, hard rock. In this case of maybe primary porosity is 0 and secondary porosity is more. What is secondary porosity? Nothing but of the in that cracks have to develop. Any cracks will be available. Those cracks are most helpful for the storage of the water. That porosity we are called secondary porosity. In this case of the hardest rocks or the igneous rocks point of, the such kind of phenomenon will be easily applicable. But in case of sediment rocks are very loose rock, very smooth rocks to compare with the igneous and metamorphic point of. So sediment rocks having more porosity and also having more permeability based on the rock type also. So those are properties should be changed based on that features, based on that properties, for physical properties point of, rock physical properties point of. Nothing but of the grain size and texture and structure and geological formation point of, those will be changes. And let me know detailed discussing about the porosity point of. So think of porosity as the fullness of the rock. It is the percentage of the rock total volume that is made up of pores or maybe voids. These voids can be spaces between individual points in sediment rocks, fractured or maybe solution cavities. Higher porosity generally means a rock can hold more water. So already I told with you nothing but of the what is meant by porosity, nothing but of individual total volume of that rock point of how how many individual spaces will be there, how much of the pores or spaces will be available, how much of the area, pores and spaces or maybe interfaces will be there in that rock, total volume of the rock, that we are called porosity. It will be represented percentage ratio point of only, nothing but of the IV by maybe total V into 100, volume of voids VV by total TV, total volume of the material into 100, that represented by the porosity point of. So nothing but porosity as a percentage point of. What we are saying here, maybe as sediment rock point it will be useful because of those are having more voids and spaces and interfaces will be there, but as the hardest rock point of, we are saying fractures and solution cavities. So fractures means nothing but of the to the compression force point, lateral force point of the rock will be displacement, then we are called as the fracture. It simply displaced, separated by the rock, separated by the rock segments, that we are called fractures. Solution cavities means nothing but of the rock will be contact by any underground water, the rock where how much of the water will be contact that particular rock, the rock will be dissolved, then creating by the solution cavities. So nothing but of the what mean porosity, nothing but higher porosity, generally rock can hold more water, or we are simply saying one line point of porosity is ability of storage of the water. A rock ability of storage of the water, that we are called porosity. The same line what we are saying here, higher porosity generally means a rock can hold more water. Porosity high, indirectly it means the rock storage of the water, more water will be storage in that one. So see that the Fager diagram point of spaces will be there, that whole point of maybe white particles. So nothing but of the rock, maybe that rock hard particles are white, remaining spaces are indicated by the nothing but of the porosity point of. Okay. Next, see here space very less. First one clay size point, soils point of, and also coarse sand soils point of, and gravel soils point of. Based on sizes, it will be maximum porosity will be there. For example, you take clay, cotton clay having more porosity, but permeability is 0. If you take sand soil, porosity is less and permeability is more. Based on that interconnect of pores and voids and also hot particles point of, it will be depend. Next one, permeability. Permeability describes how easily water can flow through a rock. It determines the size and interconnectedness of the pores. Even if a rock has high porosity, if these pores are not well connected, water won't be flow through it easily. So my dear student, nothing permeability is nothing but of the ability of to transmit the water. That a rock should be having ability of transmit the water, that we are simply said permeability. When will be permeable? Because of the what we are having pores and spaces well connected to each other in the rock, then only those connected pores as well as creating as well as working like a pathways. With help of pathways, the water should be travel one place to another place, then we are considered as a permeability nature. In case of those pores or spaces or voids are not able to well connected in that formation, rock formation, those rock having permeability nature is very less. That kind of rock formation cannot be transmit the water, cannot be able to flow that water, cannot be cannot in this case of water won't be flow through it easily. So because of first of all structured pores and voids and spaces should be presented in that one, those pores and voids should be contact easily. So with help of that so maximum they will easily move with help of that we are called permeability. Okay, nothing but of those what we are connected pores will be the creating pathways. With help of pathways, those will be moved or displacing water in subsurface, that we are called permeability nature. Okay, the representative of the first figure is nothing but the water will be entered to the surface of the to subsurface point of. If in case nothing but of the different type of rock size will be there. So the sorting is nothing but of the pool sorting will be there. Pool sorting point of between different types of rock particles or maybe particles will be there. In that case, the spaces will be more available. So easily water will be transferred. The same time of nothing but same sizes point of or maybe irregular point of. So maybe same size particles will be there filling that one. The sorting is very high. So that case of having low permeability. See here, maximum not having more spaces. So particularly the water not able to move through downwards direction. Maybe in this case of having some spaces, because of this is hot consolidated material. Because of this ground color represented by the cap space. In this space they have easily utilized for the water as pathway point of the water will be simply easily move downward direction. So upward water simply move downward direction here with help of the in between spaces or maybe pathways of the rock formations. So based on that, how well connected spaces will be one of the helpful content for the permeability point of. Next one. So rock types and their influences, unconsolidated sediments, sandstones type, one of sediment rock, limestone one of the sediment rock, and igneous or metamorphic rocks are the very toughest rocks, and shale. So different types of rocks will be there. Based on the rock properties point of the groundwater will be moved, the groundwater will be affected. So first one, unconsolidated. Consolidated means nothing but a compressed and compact and solidification. Consolidated means not to be solidified, not to be compressed. Unconsolidated, sand or gravel. So these often have high porosity. Generally sand or sandstone having high porosity and permeability, high porosity permeability also. Because of these spaces will be more have that storage of the water. Those spaces will be helpful for transmit of the water. So generally unconsolidated sediments of sand and gravel, these are often having high porosity and good permeability condition, good permeability nature. So making them excellent aquifers according to the physical geology as a guide point of view, or according to the physical geology point of view, we are saying these statements. Sandstone can be good aquifer. Sandstone is nothing but of the sediment rock. Three types of rocks will be there: igneous and sedimentary and metamorphic rocks. To compare with igneous and metamorphic rocks are the very toughest rocks to compare with the sediment rocks point of, and sediment rocks are the very loose rock, not to be that much of tough rocks to compare with the igneous and metamorphic rocks point of. Sandstone can be good aquifer due to its porous nature, and but cementation can reduce the permeability. So generally sandstone having good permeability is good for storage of the water, nothing but the porosity high, but permeability having low. When the rock will be having cementation, it will composed by it will be arrested by the holes with clay material point of, or may fine material point of, then it will be low having permeability nature. Okay, so limestone, its permeability can be significant and increased by the solution weathering with creates fractures and channels. So limestone having nature, when it will be compact of the any water content with surface or subsurface easily dissolve. The limestone having very fine grain texture, but easily dissolve when we do contact of the surface water or subsurface of the water. So then it will be creating some of the pathway channels, and also creating channels, and also subsolution cavities, subsurface solution cavities also easily weathered. Nothing but what is being weathering, nothing but of the hard rocks would be counted as a soft rock. The entire process we are called weathering. So with helping of weathering, or maybe contact with water or surface water point of easily dissolved, then it will creating by these solution weathering solution cavities in subsurface, or maybe water passing channels, or channels also, or maybe canals also. Okay, next one, igneous rocks and metamorphic rocks. So these are, first of all, I already told you, already so many times discussed with you, maybe those are the rocks are very toughest rock, hardest rocks, but low porosity. The primary porosity is very zero, or maybe sometimes very low. When the weathering of rocks or weathering conditions will be there of the igneous and metamorphic, that type of condition having some porosity, but is very tough and stiff or not having a weathering condition, that time not having any porosity and porosity because of very, when generally we are saying low porosity. So permeability also, when porosity not available, and also permeability also not able to available. So if in case porosity have, maybe chance of the permeability. In this case of igneous and metamorphic rocks not having any porosity, so not able to having any chance for the permeability secondary point of. But fractures can create localized zones of the high permeability known as a geological guide. So nothing but when having variability at porosity point of, maybe those rocks are maybe igneous and metamorphic rocks are getting more pressure, maybe compressible, lateral pressure or tectonical force point of. Any cracks are available, those cracks with help of those cracks should be the water will be storage in that cracks, that we are called secondary porosity. If in case secondary porosity will be there, those cracks working like a pathways to flow the water one place and another place, that we are called permeability. Nothing but with help of cracks the water should be moved one place and another place, and we are called as permeability. So what we are saying here directly and simply, igneous rocks and metamorphic rocks are very toughish rocks. Those rocks having low porosity and permeability. When in case having any cracks or fractures will be there and joints will be there, faults will be there, those are helpful for storage of the water indirectly, porosity having chance. So with help of those cracks or fractures, the water should be travel one place and another place, then we are also called permeability. So with help of geological guide point of we are give the statement also. Okay, geology point of, physical geology point of, or structural geology point of, we are given the statement also. Shale typical has low variability and porosity due to its fine grained nature and compaction. Shale, nothing but the sediment rock, but having like nothing but like a clay formation. So second level of the clay we are called shale formation. Nothing but of the shale has very fine grained formation we are called the slate. Slate fine grained formation we are called the clay. So nothing but of the based on grain size point of clay and shale and slate, or the both are same type of degradation point of same one type of material, based on the grain size point of view should be classified or differentiated. So in this case of differentiated, in this case of those fine grain system, mostly one of the main causes for the low porosity and permeability also. Yes, porosity point of having some sufficient porosity will be there, it absorb, but the water, what was absorbing the water in course, that should not be transported or maybe transmitted, or it should not be permeable. So she will have that kind of nature. Okay, so different kind of rocks will be there based on the nature point of the water levels or water quantity of water, groundwater levels will be decided, will be dependent on that one. Okay, next one. Rock properties affecting groundwater point of secondary permeability. We are discussing about secondary permeability. So already I told you fractures and faults and solution cavities can significantly enhance the permeability of rocks, even those are the generally considered impermeable. Yes, fracture, faults, solution cavities can only significantly enhance of the permeability. Otherwise, those are the generally considered as impermeable. Impermeable. The water will be moved through that of the material or formation that we are permeability nature. The water should not be transmitted, should not be traveled, should not be displaced, should not be moved through the material that we are called impermeable nature. So secondary permeability, when we are applying, nothing but those rocks are having, those materials are having any crack, any fracture or any solution cavities, then only we are considered, we are discussing, we are noted about the secondary permeability. So enhance the ability of rock to store the transmit groundwater is function of its porosity and variability, which are in turn influenced by the factors like grain size, sorting, sedimentation, and presence of the fractures or solution features, and also including of the sorting nature are the factors of the grain sizes, and sorting, sedimentation. These are the additional elements also be caused for secondary permeability. If having good sorting, one type of permeability will be there. It having poor sorting, one type of permeability will be there. It having grain size fine, one type of permeability will be there. If having large grain size, having one type of the permeability. So having sedimentation low and high point of also be decided by the permeability. Based on the additional factors, elements also be decided for the secondary permeability also. Okay, next one. So the image is also given here. So fractured zones and maybe nothing lineation formations or maybe weathered formations. These are also weathered formation. These are also cracks, number of cracks. So first of all, nothing but a joint or maybe a parallel joining system. Number of cracks and joining system will be available here. So nothing but of the lineation formation and is represented by the nothing but of the weathered conditions starting is nothing but the high weathering conditions. So these are the features also be decided for the groundwater. Okay. Next, and finally, I'm ready for concluding this section. I hope to understand everyone. My dear students, if you have any doubts, please contact me or text me, as well as I will reply as my knowledge point of. So I'm concluding this section. We are going to meet next class or next section, next video class lecturer. I hope you understand everyone. And finally, thank you very much.